Autodesk Helius PFA supports explicit analysis types for dynamic behaviors of composite materials, such as this impact of a steel ball onto a cross-ply laminate. Explicit analyses are much different than their implicit counterparts because they use the rate at which the event is occurring to drive the simulation. The rate at which the dynamic event is occurring can be very important because the vast majority of composite materials exhibit strain rate dependence, and that their material properties can change depending on the rate at which the deformation is occurring. In the aerospace industry, a common concern is the damage induced to a panel from a bird strike. Often, bird strikes will be tested by impacting a panel with a small projectile, such as the sphere shown on the screen. The goal of bird strike testing is usually to determine the threshold velocity, which is the velocity at which the projectile will not completely penetrate through the entire plate. For explicit analyses, Autodesk Helius PFA deletes any element which exhibits fiber damage to ensure that there is no excessive element distortion. In the viewer, blue indicates no damage and green indicates matrix damage. The differentiation of matrix to fiber failures is key to ensuring the damage can propagate accurately. Here is a comparison of the residual velocity to those from experiments. The red line indicates the simulated values using Helius PFA, while the triangles represent the experimental data from the same panel. The simulated threshold velocity, which is the maximum initial velocity which does not result in full penetration of the plate, is predicted to be within 7% of the experimental value.